Hello everyone. Good morning.
Morning, Sai.
Good morning.
Good morning.
Good morning everyone. Shall we start our class?
Yes, sir.
Yeah,
Yes,
sure. Okay. So in our last class, we have seen what is IAM, how to grade users, how to grade groups, how to deal with permissions and roles, and also AWS command line interface and different types of policies, right? Inline policies, manager policies, custom policies. So all those things we have seen in our last class. In today's class, we are going to start a new service, that is VPC. But to understand VPC, you should know basics of network. Okay, you should know basics of network and its concepts. Okay, so those we are going to learn today, the networking related concepts. So once you are good with this one, then Monday onwards we are going to start VPC. Okay, so today we are going to see network and its related concepts. Okay, is there anyone from network background in our class? Anyone?
My BTech branch was electronics and communication.
Okay, Rahul Kumar, right? Okay. Others? Anyone network related? Anyone CCNA certified? Is there anyone? Okay. Yeah, Utkarsh, you also?
No, sorry. I was saying that this is my first certification. No,
This is, I did not get you.
this is my first certification.
This is your first cert. Which one is AWS you are talking about?
Yeah.
Acha. Okay, fine. Okay, no problem. So let's see what is this network all about. See guys, network. What is network? If someone asks you what is network, then what do you say? Networking, it is a connection between two or more machines. Machines could be computers, could be mobiles, could be any electronic devices. Okay, it is a connection between two or more machines. Why are we connecting? First of all, to establish communication so that they can able to communicate with each other. Okay, that is what. For that we are having network. Network means it is a connection between two or more. Minimum two, could be more. Two or more machines to have communication between them. Just connecting them doesn't make any sense. Correct or not? Okay. If you connect them, then it doesn't make any sense actually. Why are we connecting? So that they can able to communicate. They should be able to communicate with each other, right? That's why we are connecting. Then we can say that these two machines are in one network. Okay, fine. So network components. If you want to have this kind of network, what are the components that you need? Okay, what are the components? If you want to have one, machine, I mean in laptop, you need some components like motherboard. You need hard disk, you need RAM, you need keyboard, you need one mouse, you need one monitor, right? You need one processor. So many things, right? Then only if you assemble all these things, then only you'll get one laptop or computer. Correct? In the same manner, if you want to have network, then you need to have some network components. Okay, minimum. See, there are so many network components are there, guys. There are some bridges, hubs, routers, switches, a number of things are there. Again, networking is a kind of ocean. Okay, so we need many more things. But if you want to have network, what are the minimum things that you need? Minimum. Okay, minimum. So these are minimum that you need. Okay, if you want to have a network. The first one is NIC. Also, we can call network interface card. NIC we call network interface card. Network interface card means is your laptop. In your laptop, you might have observed where you insert RJ45 cable, internet cable. Okay, internet cable. There you can see one female socket where you insert RJ45 cable, right? That socket we call NIC, network interface card. You can verify in your laptops. Okay, there where you insert your internet cable. Okay, that we call network interface card, NIC. Okay, then what is media? Media is a medium via which you connect two or more machines, NIC cards. Okay, it's a medium via which you connect two or more machines, NIC cards. This could be wire. This could be wire or could be wireless. That could be wire or wireless. Okay. Then topology. Topology means how are you connecting? Like if you have so let me tell you. Suppose see if you have 4 machines are there. You can connect like this, like ring type. You can connect like this, like lane. You can connect like this. You can connect like this one, or you can connect like this. Okay, so how you are connecting all these machines? How? What kind of design? What kind of pattern that you are following? That is what we call topology. Ring topology, lane topology, now mesh topology, star topology also is there. Star topology. Okay, tree topology. Like we have different topologies are there. How you are connecting? See, you are connecting 2 machines, right? How you are connecting? What kind of design? The pattern that you are following. Next, protocol. Protocol means the actual meaning of protocol is procedure. The actual meaning of protocol is procedure. What are the guidelines that you need to follow? Standard practices that you need to follow. Okay, protocol. You might have heard, right? Whenever any VIP visits and all, when it happens, in these news channels, they use this word protocol and all. Protocol means the standard procedure, rules to be followed, established guidelines, procedure. That is what protocol. Simple example. So whenever any foreign abroad country's head, could be prime minister or president, when he visits India, who should go and receive him? Wherever he is landing, that state CM governor, they should go and receive. That is a procedure. Okay. So that's what standard procedure should be followed. That is what protocol. Okay, established guidelines, rules to be followed. That is what we call procedure. Okay. So here this protocol deals with ports here. Ports. That means when 2 machines, when they communicate with each other, that communication happens through ports. Correct? So what kind of procedure to be followed while they are communicating? What are the rules and regulations should be followed? Okay, so that's what protocol over here. Then the final one is IP address. IP address means it's like a name to your machine. Name. Okay, numerical name. Because you can't give normal names, right? Like Sai, Raj, you can't give these kind of names to machines. That's why you're giving a numerical name in a number format. Okay, just like we have our names, every machine will have one IP address to identify. What is the purpose of IP address? So that each machine can able to identify each other machine with that name. Okay, each machine can able to identify each other machine, okay, in a network with that IP address. Okay, it is a numerical label that we assign to every machine. Just like we have phone number, right? Same like machine has IP address. Okay. So these are the components that you need to have network. Minimum, you need these components. Maximum, there is no limit. Okay. So let's do deep dive in these things one by one. Again, guys, you need not to be perfect in network. That is not at all possible also, because we have separate courses are there, network related courses are there. Okay, so need not to be perfect, because in companies we maintain network teams. They manage all these things, but you should have knowledge. Okay, see, you are driving one bike. It doesn't mean that you should be a bike mechanic. No, but at least you should know what is what, basics. Correct or not? So that's in the same manner. Here also you must know what is what. This is not only for AWS and all right. You being a IT guy, you must know basics of network. Being IT guy, could be any department. Okay, could be a developer, tester, DevOps, AWS, data science, could be any. Okay, you should know basics of network if you are an IT employee. Remember that. Yeah. So first one, as I said, 5 components, right? See, NIC, media, topology, protocol, IP address. NIC, network interface card. It is a computer hardware. It is a hardware component, guys, in your laptop. Okay, that connects a computer to another computer in a network. Okay. Each NIC will have its unique MAC address. MAC means media access control. It is a physical address. Every hardware component will have one MAC address. Every hardware component. Okay. Every hardware component will have one fixed MAC address. Fixed. Every hardware component. Okay. So see, every hardware component will have unique MAC address. Unique. That means you can't find 2 MAC addresses in this world. You can't find 2 MAC addresses having the same name. No, that is impossible. Every component in this world will have unique MAC address, unique. To avoid conflicts between these adapters, NIC, when they communicate with each other, NICs, they communicate by using MAC. Sometimes IP conflict occurs. IP conflict may occur. Okay, 2 machines can have same IP. Okay, that I'm going to explain. What are the instances where 2 machines can have same? That I'm going to explain just in a while. That's why there could be IP conflict, but there can never be MAC conflict. Okay, remember that. So generally we represent these by using ETH, INS, these words. ETH 0 means 1 MAC address. Okay, ETH 0 means 1, 1 means 2, 2 means don't worry. Don't worry about these things at this time, but understand one thing. Each hardware component will have one unique MAC address, that is also we can call physical address, that is unique in this entire world. That's it. Generally, we refer them with these naming conventions: ETH 0, ETH 1, like that, or ENS 0, ENS 1, like that. Okay, fine. Media. It is a medium via which 2 NIC adapters will be connected. Okay, so that, as I said, that could be wire or wireless. Example is RJ45 cable. What is this RJ45? It is just a model of the cable, internet cable that you use. We have RJ11 is a model type of cable. What kind of model? Okay. So as I said, that could be wire or wireless. Topology. It is a design in which the computers in the network will be connected to each other. Bus topology, ring topology, star, mesh, tree. Different topologies are there. Protocol. It defines rules and conventions. Rules and conventions. Simple, guys. Rule is something that you need to follow. Mandatory. If you don't follow, you'll be penalized. You'll be behind bars. Convention is something that you need not to follow, but it is good to follow. It is better to follow. Okay, better to follow. See, simple rule. You should not jump traffic signal. You should not jump traffic signal. That is rule. If you don't follow, you'll be penalized. That is rule that you have to follow. Convention is like, don't overtake. Okay, please don't overtake. That is just advice. You can overtake. Okay, there are some roads where you can overtake, but that is not advisable. That is what convention. Okay, convention is something, it is better to follow. Okay, it's just advice. Please don't do that. That's for your benefit only. See, we are celebrating festivals. Is there any mandatory rule that we need to celebrate? If you don't celebrate festival, I'll put you in the jail. Is there any rule from government side? No, right? Why are we celebrating? That is a convention. That's what, our ancestors, they followed, and we are following that one. We are taking this one to our next generations. It's a good practice, culture, custom, tradition, whatever you can call. Okay. So this protocol defines rules and conventions. What are the mandatory rules and what are the good practices for communication between two network devices? See, these are two devices. When they communicate with each other, what are the rules? With the ports, they communicate, right? Okay, what are the rules? Mandatory rules, established rules, and what are the good practices should be followed? That deals with ports. Okay, protocol. IP address, as I said, it's an internet protocol address. The full form is internet protocol. Okay, it's a numerical label, but it's a numerical in nature, assigned to each device connected to a computer network for communication. Okay, just like a phone number. Every phone has phone number, like that. Yeah. So now let's go deeper into these things: protocol and IP address. Protocol. So as I said, protocol means procedure, right? Rules, guidelines, whatever you can call. See guys, how many ports are there in this world? There are, every machine has 0 to 65535. These many ports are there. Every machine has these many ports, 0 to 65535. Just like a room having doors, right? Okay, you could have any number of doors, but there will be a limit, correct or not? So here also same thing, every machine has these many ports, max. Okay. Just like, see, human population in this planet divided into two categories, right? Male and female. Human population is in millions, billion, trillions in number. But the entire human population is divided into two categories. One is male, another one is female. Male population and female population. In the same manner, these many ports, all these ports divided into two categories. Okay. Some ports come under TCP category, some ports come under UDP. Okay. So I'm repeating, guys, all these ports divided into two classes or categories. Some ports come under TCP, some ports come under UDP. Okay. What is TCP and UDP? This is a procedure. What kind of procedure that it is following? Okay, whether some ports follow TCP procedure, some ports follow UDP procedure. That's why we can call protocol. Okay, fine. Let's try to understand what is the difference. TCP full form is Transmission and Control Protocol. UDP full form is User Datagram Protocol. That's the full form. Okay. It is connection oriented. It is connectionless. So what is this connection oriented, connectionless? Don't think that wire and wireless. No, guys, that is not the case. The meaning of this line is in next line. TCP acknowledgement will be sent and received. That means when communication happens between machines having ports which are coming under TCP, when they communicate with each other, for every transmission, one acknowledgement will be received. Right, acknowledgement. When you send any message to your friend, you'll get one acknowledgement that, hey, your message has been delivered successfully. Correct? WhatsApp is, that could be in any form. If you send normal message, you will get one acknowledgement back in the form of message that your message has been delivered successfully. Correct? Okay, you got one courier that product in Amazon. Then you'll get an email that your product has been shipped, delivered. Those are acknowledgements. In WhatsApp, when you send any message, okay, then you'll get two ticks, right? 2 tick marks. That means yes, your message has been delivered. These are acknowledgements. So when communication happens through the ports which are coming under TCP, for every transmission, acknowledgement will be received. Okay, that's why it is connection oriented. That is the reason. But the same thing happens when happens through the ports which are coming under UDP. There won't be any acknowledgement. Only one way communication. No acknowledgement. That's why it is connectionless. That is the reason we call it connectionless. Since for every transmission, you'll get acknowledgement back, that's why it is slower communication. You'll get acknowledgement, then one more transmission like that. So it is slower communication. But since it doesn't need for that acknowledgement back, that's why it is very fast. It is faster communication. Okay, that's it. Since it is taking acknowledgement back, that's why it is secure. Even though it is slow, but it's secure. It is fast, but not so secure. Not so secure, but faster communication. Okay, that's all. Understood? Now, if you want, see, same difference. Bike is there. If you want more pickup, then mileage, you will get less mileage. If you want good mileage, then you won't get that kind of pickup. Correct or not? Same thing. See, there are some ports where security is must. Security is must. Even though communication is slow, no problem. But communication must. Those ports are coming under TCP. Okay, HTTP, HTTP, these are. There are some ports where we don't need security, but that should be faster communication. Okay, so those ports are coming under UDP. Okay, that is it. See, as I said, all these ports, out of all these ports, as I said, some ports follow TCP procedure, some ports follow UDP procedure. You can say some ports follow TCP protocol, some ports follow UDP protocol. These are two procedures, rules, two types of procedures that these ports are following. Okay, so at least you understood the basics of TCP and UDP. I mean, again, there are many things to discuss which are not actually required because that's internals of network. Those network administrators, they will learn all these things. These are basics. You must know what is what. Okay, fine. Then coming to IP addresses. IP addresses. Okay, can someone tell me how many IP addresses are there in this world? Anyone? What is the first IP? What is the last IP? Anyone? What is our first IP? Anyone?
Maybe one.
Maybe
255.
255.
0001.
000.
0
Zero.
3 times 0 and 1.
Okay. 2
0 0 0 0 255
255.
255 255
255
180.10.32.1.
50 dot.
What?
What 182 dot 10 dot
10.32.0.
192 also it might be.
92. Okay, any more? That's it.
Yeah, these are the IPs like which I've seen in my company.
Okay. Okay. Fine. Let me explain. See guys, the first IP address is 0.0.0.0 and the last IP address is 255.255.255.255. This is the first IP, this is the last IP. Okay, so this we call IPv4 version 4. This is of 32 bit, we call as 32 bit. Okay, I'll tell you why it is so. See, you understand decimal 0, 1, 2, 3 till 9, correct? You understand decimal number. Decimal means 0 to 9. Total 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9. Machine will not understand decimal number. Machine understands binary, 0 and 1 only. Okay, when you give any input to your machine, when you give any input, backend that will be converted into respective binary. Respective binaries. Machine will convert that decimal input from you into respective binaries. Okay, for example, this is there, right? This will be converted into like 100101010. Okay, just as you, I'm giving an example. This number would be 001101010. Could be this 101101 something. Total 8 only, yes. This number would be 010 something. Okay. Now see here, each one we call, each one is 1 bit, total 8 bits. Here also 8 bits, 8 bits, 8 bits. 8 plus 8 plus 8 plus 8, total 32 bit. Okay. So this machine will convert your decimal into respective binary. Okay. Each one, when you give any, that see each number will be converted to respective 8 bits. So total how many bits? 32 bits. That's why IPv4 is 32-bit we call. But there's a shortage in this IP address because right, every machine should have one IP assigned, correct? But there are machines are growing like anything in this world. Okay, every machine should have an IP. So there are so many machines coming up in this world, but IP address is fixed. Okay, problem with IP address is this is fixed. Machines are growing, number of machines growing, but not IP addresses. And every machine should have an IP address. So that's why that means there is a shortage of these IP addresses. There is a shortage. We are running out of this IP range. There is a shortage in this world. That's why to address these kind of issues, okay, recently they introduced IPv6. IPv6. This is 128-bit operating, 128-bit. Okay, 128-bit. This contains alpha plus numeric characters. Alpha plus numeric. Here you can see only numerics. But IPv6 contains alpha plus numeric characters. Let me just show you here. IPv6 example. You can say something like this. You can say something like this. Alpha plus numeric characters. This is never-ending IP range. Okay, never ending. Okay, this will never end, that kind of IP range. So that again, we should not face these kind of issues again and again, right? That's it. Okay, never-ending IP range. Now AWS is supporting both. Okay, recently started supporting both AWS. So IPv4 and IPv6. That anyways, I'm going to show you in our class itself. Okay, fine. That's okay. This is unnecessary actually for us. Right now we are using IPv4 only, even though they are introducing IPv6. Still, we are using IPv4 only. Okay. So as I said, the first IP is 0.0.0.0, and the last IP is 255.255.255. These are last IP. Since we have so many IP addresses are there, that's why it is, see how they calculate. Observe carefully. These are first IP. Second is going to be 0.0.0.1. Third IP is going to be 0.0.0.2. Like that, one fine day it will reach 0.255, right? Then for 250 is a dead end. Then 0.0.1.0. You can see previous number, this number will be modified. 1.0, again 1.1. Then one fine day it will reach to 0. 1.255. Then again 0.0.2.0. Like this again 2.1. Then finally it will reach to 255.255. 0.0. Then 0.1.0.0. Like that. So finally, one day, again it is going to be 0. 255 dot, 255 dot, 255, and finally, then after that, see, then after that, 1 dot, 0 dot, 0 dot, 0, like that. Finally, the ending IP address is going to be 255 dot, 255 dot, 255 dot, 255, and that is this one. Okay, that is how we calculate. Understood? So these many IP addresses are there. This is the first IP, this is the last IP. Okay, and we call these as ranges. 0 dot, 0 dot, 0 dot, 0, 2, 0 dot, 255 dot, 255 dot, 255. See, 0th range, you can see 0. Then after that, 1 dot, 0 dot, 0 dot, 0, 2, 1 dot, 255 dot, 255. This is one range. Again, 2 dot, 0 dot, 0 dot, 0, 2, 2 dot, this is 2 range, second range. 0th range, first range, second range. Like that, how many ranges are there? 255 dot, 0 dot, 0 dot, 0. 255 dot, 255, these many ranges. That means how many ranges are there? 0. See, starting from 0, right? 0 also we have to include. So that's why 256 ranges are there, 256 ranges. Because 0th range also included, right? 0th, 1, 2, 3. So 256 ranges are there. Range means 0th range, starting from 0, ending with 0. That's all. 0 dot, 0 dot, 0 dot, 0 to 2. Then 1 range, 2 range, like that. 256 ranges, IP ranges are there. Just remember that. Okay. Now, since we have so many IP addresses here, that's why it would be difficult for us to identify IP address. That means, see, if you have, I'll give one example. If you have 500 books in one bag, 500 books in one bag, okay. Then if I ask you, hey, pick so-and-so particular so-and-so book, then for you it takes a lot of time, because out of 500 books, you need to verify where is that book. It takes a lot of time, correct or not, to pick that particular book, right? So if you want to pick quickly, then what you can do, you keep 5 bags, or that's as per your requirement. You keep 5 bags, you keep 100 as per the subject wise. Okay, then you give names like A, B, C, D, something. If I ask you to pick one book, then you know what is the subject. Then you go to that particular book, you can pick. This is very easy, right? Correct or not? So in the same manner here also, since we have so many IP addresses are there, that's why it would be very, very difficult for us to pick one particular IP out of this big range. Okay, that's why for our easy understanding, easy identification, easy to pick, okay, they have divided all these IP addresses into classes. They have segregated all these things as per the class. So we have total 5 classes are there: class A, class B, class C, class D, class E. Total 5 classes are there. Okay, here you can see. Class A starts from 0.0.0.0 till 256 case. It's not 7, 256. Just make it 256. Sorry, 126. 0 to 126.255.255.255. Okay, don't worry about this part as of now. So this comes under class A. Okay, that means 256 ranges. Ranges are coming under class A. Then class B, 128 onwards, 191. This is coming under class B. 192 onwards, 223. You can see 192.0.0.0 to 223.255.255. That means 192nd range onwards till 223rd range. These many ranges are coming under class C. Then class D, 224 to 239, and class E, 242, the final one, 255. Okay, that's how we have classified, segregated as for the class wise, A, B, C, D, E. Okay. Now, so here, how many ranges are there in class E? 0 to 126. If I take round figure, okay, here we have 125 classes are there. 125 ranges are there. I'm taking round figure there. Here 128 to 199 means around what 30, 60. Around 60 IP ranges are there. Here class C around 30. And here class D around 15. Class E 15. You can see 125 around ranges are there in class A, class B 60, class C 30, D and E 15 only. Okay. Now what you do, you can take any IP address from any of these classes and you can assign to your laptop, your machine. I'm repeating. You can take any IP address from these ranges. You can assign to your laptops, your machines. Okay. But not these two, except these two classes. Class D and class E are reserved. You cannot take any IP address from these two ranges, these two classes, class D, class E. Anyway, see only 30 only if you combine both. They are reserving only 30 ranges. Remaining that biggest range, 120, 60, around, 210 something, 220. Okay, these many, ranges, these many addresses you can use, but not these two, class D and class E, because they are reserved. They are reserved. Class D and class E are reserved. Why are they reserved? For which purpose? See here, class D is reserved for multicast. You cannot take any IP address from these two classes because they are reserved, and this class D is reserved for multicast. Multicast means, see, we have three terms are there. One is unicast, broadcast, multicast. Unicast, broadcast, and multicast. Unicast means one-to-one communication, that we call unicast. Broadcast, one to all across the globe, wherever that frequency reaches. One to all. Right? This radio transmission, radio communication is a broadcast communication, correct? That you might have heard, right? That means from that particular radio station to across the globe, wherever that frequency reaches, all 360 degrees. Okay, that's all. So radio communication is a broadcast communication. So that, one cricket match is going on somewhere in London, from that cricket stadium to across the globe. Okay, that's what broadcast. Multicast means one to selected. One to selected, this one, that particular one. This one. See, broadcast means one to all. Multicast means one to selected, few. That one, this one, selected. So whenever this kind of communication is there, one to selected, okay, this kind of, for that communication, those machines, they assign these IP addresses to those machines. Okay, these. So it is reserved. So we should not use it. This is reserved. Okay, they use these IP addresses for multicast communication. This is one thing. Second thing, class C. This is reserved for what? For R&D. R&D means research and development. Okay. So whenever they invent any new machines, new electronic items, they have to test before they release to market. Okay. So for testing purpose, that time they use those machines will be assigned with IP addresses which are coming under class C, research and development. Okay, how they do it and all, that's unnecessary for us. Yeah, just remember one thing, these are reserved. Apart from that, one more IP range is reserved. One more IP range. You might have observed here. Here ending with 126. Ending with 126. But here starting with 128. So what is that missing IP address for range 127 range? See, this entire 127 range reserved for loop back. These also reserved. Loop back means this is mainly for testing purpose. See, this is machine A, this is machine B. If I want to test whether machine B is reachable or not, then what I do in machine A, I type ping machine B's IP address. Ping machine B's IP address. Then the packets, network packets will go to machine B and packets will come back. Then I can say, yes, machine B is reachable. Correct? See here. I want to verify whether Google server is reachable or not. Here what I do, I type ping either Google's IP address or Google DNS name. Google.com is its DNS name. Enter. Then here packets are going and coming back. That's how we can test whether any machine is reachable or not. Okay. So here, why are we using this one? Just for testing whether machine B is reachable or not. Right. For that, when you do these kind of things, okay, backend it uses IP address from this particular range 127. Okay, this is what we call loop. See, this is loop back, loop back, loop back. This is for testing purpose. Okay, so backend it uses 127 range. Okay, so summary of this entire discussion, whatever we did till now, in that simple D, class D, class A, and 127 ranges are reserved that we cannot use. Apart from these three, we can use any IP address from any class we can assign to our machines. Okay, remember that. Now here, you understood. Suppose if I say that if I give any IP address, you should be able to say that that comes under which class. Can you say that or not? Guys, please respond. If I say, okay, 195, 0.0. something, that comes under which class? 195?
Class C.
Class. Okay, 100 dot something, that comes under which class?
Class A.
Class A. Okay, just remember that much as of now. Okay, so here we have one more concept is there called subnet or subnet mask. Either you can call subnet or subnet mask. You might have observed when you find any IP address like 10.0.0.0 could be any IP address. They put one slash and they give one number here. Correct? That number ranging from 0 to 32. 0 minimum, 32 maximum. You can't find 33, 34, no. 0 to 32 only. Did you observe guys this one anywhere? Did you see like this? IP address slash some number?
Yes.
Okay.
Yes,
yeah, that is there in our, in fact, in our AWS account. I'll show you. Go to EC2. Now go to security groups. Let me take any security. Okay, Psi group. Yeah. In modules, edit. Here you can see 0.0.0.0 slash. You can see slash 0, right? Okay. Instead of custom, if I take my IP, if I select my IP, you can see some IP address, right? Could be any IP address slash 32, right? So what is this all about? Why are they giving those numbers? That number only we call subnet or subnet mask. I'll tell you what actually happens. Suppose you have one machine, you want to assign one IP address. You want to assign, okay, I want to assign this particular IP address. Okay, you are assigning this IP 10.0.0.0. But backend, unknowingly, you are blocking entire range. See, you are thinking that you are assigning only one IP. That means you are blocking only one IP address. That is 10.0.0.0. But unknowingly, backend, you are blocking entire range. That means 10.255.255.255. Okay. So that is how they design. That means if you use any IP address from any range, others cannot use any IP address from that entire range. That is how they design. That means you are not letting others to use. Simple example. There's a plate. Only this portion only you can see, and you are eating food in that plate. Food is there in that remaining portion of the plate. Okay, you are eating and you are going away. So others cannot touch this plate, right? Again, correct or not? You are thinking that you are eating only this much. Yeah, that is fact. But since everything is in same plate, others cannot touch this plate, right? So you are not eating this remaining portion of the plate. You are not letting others to eat. Correct or not? Okay. So that is a problem here. That is how they designed. That is how. Okay. So that's a problem. If that happens, then anyways we have very limited IP addresses in this world. There's a shortage, and on top of that, you are not using them, and you are not letting others to use, right? So this should not happen, right? That's why they introduced a concept called subnet or subnet mask. Now, what actually happens here? Whenever you take any IP address, see 10.0.0.0, you put one slash, you give the number. Maximum is 32. Okay, assume that I'm giving 30. So what is this? Whenever you see any number here, first you take the maximum number. Maximum is 32, right? From that you take this particular number, subtract. From maximum number, this subnet number you subtract. Then output you will get 2. You put one more 2 here. 2 power 2. That is 4. Okay. That means you are blocking only 4 IP addresses. Those are 0.0, 0.1, 0.2, 0.3. That's it. Others can use from 10.0.0.4. Okay, suppose someone is taking 0.4. If he gives 31, any number could be. 31 means maximum number 32, from 31 subtract, output is 1, 2 power 1, 2. So that means he is blocking 0.4 and 0.5, only 2 IP addresses. Others can use from 10.0.0.6. Assume that he is giving 32. Okay, so 32 and maximum number is 32, subnet number is 32, 0, right? 2 power 0 equal to 1. So here, that particular IP only. That means here you can see 32 means only one IP, that is only this one. Okay. So but again, others can use from 0.10.0.0.7. Suppose 28. So here 32 minus 28. Okay, so output is 4, 2 power 4, 16. So 16. Others can use from other IP like that. That is so. What actually we do here? Suppose I have a company. In my company, I have four machines are there. In my company, I have 4 machines are there. What I do, I take this range for this network. For this entire network, I take this range 10.0. IP address could be anything else. Just like this is an example. Your focus should be on subnet. I give 30. So here I'm getting 4 IP addresses. So each machine will take one IP address from this range. Okay, for the entire network, you assign IP range like this. So that each machine will take one IP address from that range. Others can use from this 10.0.0.4 onwards. That is so. That's why it is mandatory that you have to use subnet. I'm repeating it, simple. You take IP address with subnet and that you assign to one network, so that each machine will pull one IP address from that particular sub range from this. Okay, so that others can use from other IP addresses. See why are we calling a subnet? Out of big net, we are creating small nets. See, this is one small net, subnet. This is one more subnet, having 2. This is one more small net, or you can call subnet. That's why they are using the word called subnet. Subnet. Okay, just remember that. That is all. So I hope you understood what is subnet. Okay, at least you can calculate. For example, if I give any example like 20.0.0.0, and if I give 30, okay, if I give or 29. See, if I give 29, then by seeing this, you should understand 2 things. First one, that IP address is coming under which class? This is coming under class A. And how many IP addresses they are blocking? How many? Here, right? 32, take big number, from that you subtract this 29. Output is 3. 2 power 3, right? 8. Total 8 IP addresses. That means 1, 2, 3, 4, 5, 6, 7. So 1 means 0th also is right. So that's all. So total they are blocking 8. That is it. So two things you should understand. One is that is coming under which class and how many IP addresses we are blocking. Okay, just remember that much. This is what we call subnet or subnet mask. Okay. Now coming to public and private IP. Okay, what is the difference between public IP address and private IP address? Guys, this is simple calculation, basics. You understood, right? This one, this calculation, everyone? Okay, that's okay. Go through video once again.
Sai, one point I missed it here. Why are we multiplying with 2 bar with every time when we subtracting it?
That is how it is. Like, that's not actually multiplying. They found one easy formula to remember easy.
Oh,
Actually, 30 means 4. 31 means 2. That's how. So for that, somehow we need to figure it out to get a formula, right? That's why they have designed like this. If I say a plus b whole square equal to y, it is a square plus b square plus 2ab.
yeah, that's a formula.
That's a formula, right? Same thing. Here also same thing.
Okay.
That's
It
just
is default for
yeah.
Anywhere.
Right. Okay. So that we can remember easily. Why are we inventing these formulas and all? We can remember easily. We can get output easily. Correct? That's all.
Yeah.
Now, coming to next one. That is public IP versus private IP. Public versus private. What is the difference? See, this is IP range, right? As I said, 0.0.0.002, 255.255.255.255. So out of these many IP addresses, all are public only, all are, except a few. Out of these many IP addresses, only few are, see, out of these entire IP addresses, this entire thing is public only, public IP addresses only. But small portion is coming under private. Some IP addresses are coming under private. So what are those? Just search in Google, then you will get to know. Here, private IP address. Private IP address. Range. Yeah. 10 dot, okay, this one 120. Okay, correct. This is our, let me verify again. Yeah, these are right. Correct. See, entire 10 series, you can see entire 10 series coming under private IP. Entire 10 series. That means 10.0.0.0 to 10.2.2.2.2. Entire 10 series coming under private IP. Don't worry about this one. In 172 series, not complete series, okay, partial only, partial section coming under private IP. That is 172.16 onwards here. This one, 16 to 31 here. In 127, in that 16.0.0 to 31.2.2, this portion, partial section only coming under private IP. And in 192 series, 192.168, here, in fact, less than that, so very few. 0.02, 250.250. In the prefix should be 192.168. So out of those many IP addresses, only 3 ranges. In that also one complete range. In other ranges are the 2 partial section of that range. Okay, those IP addresses are coming under private IP. Okay, private IP. There you can see they mentioned clearly. Okay, private. Now, why? What is the difference? First of all, what is the difference between public and private? Let me give one simple, easy example. Let me take two organizations. This is one organization. This is one more organization. Let's take. You see, it is Facebook. This is Google. One is Facebook and one is Google. Two organizations are there. Two IT companies. Three machines are there. In each organization, I have 3 machines. Here also 3 machines are there. Let's give names A, B, C, X, Y, Z. See, every machine will have one private IP. One thing you have to understand, every machine will have one private IP. Okay, every machine. That too, it's not exactly same. There are some exceptions out there, but don't worry about that one. But generally, you can understand, you can think that yes, every machine will have one IP address. Every machine, one IP address. Okay, that you can verify that here IP config. Enter IP config. You can see here. Yeah, these are one. 192.168.2.104. See a private IP range, right? 192.168 series, private IP. So my laptop is having this IP address. That means my laptop is having a private IP. So every machine will have one private IP. Okay, private IP. So this is having one IP address. This is having. Assume that okay. Let's give any. How can I differentiate? Okay, 10 series I'll take 10.0.0.0 because these are coming under private IP. 10.0.0.1, 10.0.0.2. See, these 3 machines are having one private IP range, right? So that's why here what we do, we assign subnet mask. We assign subnet to this entire network so that each machine will pull one IP address. 10.0.0.0/32 something 31 like that. So that each machine will pull one IP address. So these 3 machines are having 3 different private IP addresses. In other organizations also, we can have same, no problem at all. See here, this could have 10.0.0.0, no problem at all. Here also 10.0.0.1. Here also 10.0.0.2. No problem at all. You might be having out. So you said each machine should have one unique IP address. But here in this case, both are having same private IP. No problem at all. Here the concept is in one organization, inside one organization, or you can call inside one network, no 2 machines should have one private IP. No 2 machines should have unique private IP. That means, I'm repeating guys. Inside one organization or one network, no 2 machines should have same private IP. If that machine is in some other network or other action, then that is accepted. You can see these two are having same private IP. These 2 are having same private IP. No problem at all. Okay, but the problem is if 2 machines inside one organization, when both are having same private IP, for example, these are having 0, then there is a problem. Then IP conflict. Okay, see, these also having 0, these also having 0, then there's a conflict. Because see, here, they are communicating with each other by using private IP addresses. Inside one organization, machines communicate with each other by using private IP addresses. So they are not going to communicate with the machine which is from other organization. So then there won't be any problem. Correct or not? Simple guys. In India, 2 guys are there, A and B. They are using phone numbers. One number is 10, and the other one is 11. Okay, and the other one is 11. So in India, they are talking to each other, no problem. They cannot call to the person who is from other country. So in other country also, they can use same numbers, no problem. No problem. Because first of all, this A cannot call B because they are in other country. So there won't be any issue. Correct? Same thing. That means, see, summary is summary is no two machines in one organization should have same private IP. Every machine in one organization should have its unique private IP. But other organization can have same range. Whatever this organization, Facebook is using, that same IP range can be used by other organization. No problem. This is one thing. So inside, internal communication happens through private IP. Internal communication happens through private IP. And every machine will have one private IP for sure. Okay, fine. So sometimes we get by default, sometimes we assign. How to assign that I'm going to explain in our VPC class. Okay. Now, see here also they are communicating with each other by using private IP. No problem at all. So when you get public IP to any machine, when it is connected with internet, whenever you connect any machine with internet, then internet service provider will assign public IP. For example, see here, I have connected to one internet service product model. Could be Reliance, Jio, whatever, could be any model, Airtel, any. Okay, BSNL could be. So that is what we call internet service provider. Whenever you connect your laptop with internet, then that internet service provider will assign one IP address to your laptop. See, if I want to see public IP, what do you do? Go to Google. Here, what is my IP? What is my IP? You can see what they are saying here. Hey, your public IP address. Here, public IP is 103 something dot something dot something. If my laptop's private IP, if you want to see, go to command prompt and type there. Here you can see private IP. If you want to see public IP, then go to Google and type, then you can see. See, here, since you connected to internet, that's why you can see this page, right? So that's why if you don't connect to internet, then you won't get public IP. So this is my public IP. Who assigned this one? Internet service provider assigned. Suppose if I connect to a different network, suppose here, if I connect to different network, then I'm changing the internet service provider, then your public IP will be modified, will be different. Every time you connect to a different network, your public IP will be modified. Just try, first you connect to your home address, then you connect to your hotspot, and then you again hit refresh and type. Then your IP will be changed. Okay. So now see here, machine A wants to communicate with machine X. Machine A wants to communicate with machine X. That means they are going out of network, correct? That means they have to have internet. So whenever they connect to internet, yes, internet service provider will assign one unique public IP. Unique. Assume that 132.0.0.1. Here, 132.0.0.2. Every machine in this world will have unique public IP. So they communicate with each other by using this public IP. No two machines in this world will have same public IP. No two machines in this world will have same public IP. Every machine will have unique public IP. Okay, that's why there is a shortage with respect to public IP, not private IP. Private IP can be used again and again in different organizations, but there's a shortage with respect to public IP. That's why they are introducing IPv6. Now you might be thinking, say different internet service providers are there. They are assigning. How come they assign unique public IP? Okay, how do they know that this IP public IP is blocked, reserved, or not? Because backend there is one organization called IANA. IANA. See, Internet Assigned Numbers Authority. This particular organization, which is see here, it oversees global IP address allocation. This is the organization which is responsible to manage IP addresses and also domain names. Domain names I'll talk about that one later on when I explain DNS. Okay, Route 53 and all. Okay, this organization. That means these internet service providers are backend having connection with IANA. That is so. Okay. Simple guys. Here summary is simple. 3 points I would like to explain. Just remember these two. No two machines in one organization should have same private IP. Otherwise, there is a conflict. Two machines in two organizations can have same private IP. No problem at all. No two machines in this world should have same public IP. Otherwise, conflict occurs. But just remember these three. Okay, understood? And one more thing. assigning public IP is not in our control. We can't assign public IP because internet service provider will assign that one. So that is not in our hands. What the thing is which is in our hands? We can assign only private IP range. That is in our hands. Okay, we can take whatever range that we want. Okay, with subnet, and that is of private IP, not public. Okay, so just remember this much. I know that I'm pretty sure that here you might be getting some doubts, few doubts. Don't worry, those will be clarified when I show things practically. You know, in VPC class, I'm going to show you this one practically. We are going to assign private IP manually. That time doubts will be clarified. And also one more simple small disclaimer is, you need not to perfect here. Okay, first of all, whatever we discuss, right? We don't use these many things. Okay, network teams will be there, separate network team, they will take care of all those things. But if they give any IP address, if they give any IP address, you should be able to understand three things. That IP address coming under which class? Okay, what is that subnet? That means how many IP addresses are reserved, whether it is public IP or private IP. Okay, if I give any IP address, suppose here I'm giving 10.0.0.0/30. Okay, if network teams, if they give any IP address, you should be able to understand three things. First class, yeah, this come under class E. That you know. Subnet, how many IP addresses are reserved? 30 means 32 means total 4. So 4 are reserved. What are those? 0.0, 0.1, 0.2, 0.3. Then what is the public IP or private IP? Yeah, 10 series. This is private IP. That's it. If you remember these three, that is more than enough. Today's entire class is all about just three things. Okay, so don't go beyond this one, because again we have in-depth network concepts are there which are not actually required for you. Network teams are there, they will take care of that. If you can identify these three, that's it. You understood today's class. That's it. You need not to go beyond that. Understood? Fine, guys. If you have any doubts, and one more thing here. One more thing. Group of IP addresses we call CIDR. Group of IP, for example, 10.0.0/32/30. That means here how many IP addresses we are grouping for, right? So any group of IP addresses we call CIDR, classless interdomain routing. CIDR means a group of IP addresses. That is what we call CIDR. Just remember that. Yeah, that's it for today. Yeah, if you have any doubts, you can ask me. Monday we are going to start with VPC.
Hello, sir.
Yes, please. Before that, first you tell me, guys, at least you understood at least what basics of network, IP address, classes, subnet. At least you know things, right? Now?
Yeah, yes, sir.
Yes, sir.
Yes, sir.
Question in here.
Yeah, go ahead.
Let's say, like, for example, any organization, we have a branch in India and one branch in Montreal or some other country. That can be private IPs can be the same, right? So
that yes, it can be, because when they have private IP, correct. When they have. So here, yeah, answer to your question is yes, they can have under certain.
When we access that.
Okay. Yeah, you can. Under certain scenarios, we can have private IP, private network. Okay, no problem at all. That time, private network means private IP only. Okay. Yeah. Let me add one more small point here.
Okay.
Let me add just one point. That is, you might have observed when I launch any instance. Okay. When you launch any instance, for that instance, you will get public IP, private IP, both. Correct? Yeah, public IP, private IP, both you get. But when you stop any instance here, public IP will be disabled. There is no public, but private IP is there. Okay, why it is happening? Why? Because the same thing as there is a shortage with respect to public IP. There's a shortage. You are stopping your instance, and still if you have public IP with you, that means you are blocking that IP unnecessary, and you are not letting others to use. That's why when you stop, AWS will directly take out that public IP, will allocate to any other machine. Okay, they are managing like this. They are taking IP address from my machine, they are assigning to your machine when you start. But when you stop, they will take that one, they will assign to some other machine. That's how they are managing all these IP addresses, because there is a shortage. That's why you might have observed, if you assume that you launch one machine, you are getting one IP address. You stop and start again. You stop, then start. You'll get new public IP. Okay, just observe that one. Those won't be same. Correct or not? Did any one of you observe that one?
Yes, when we connect to mobile,
yes, sir.
we can't
Right.
use the same,
Yeah. You have to
path
use
connect
new one.
to take the new
Yeah.
one.
Right, because that's why they are changing, they are taking it out, they are giving one new IP address. That is how they are managing, and those DNS names are created based on IP addresses only. If your IP is changing, then DNS will be modified. Every time you are getting new public IP, then you will get new DNS name. That's why every time you connect your machine, you have to use that latest public IP, not the old one. Things will not work if you use old one. In some cases where we use private IP also, that I'm going to show you. In VPC class only, we are going to learn where we use private. And also see, right now I'm in Pune. My machine is in Mumbai. That means two different networks completely. So obviously that's why to connect to Mumbai, this instance, I'm using public IP only. Okay, because they are in two different networks, that's why we use public IP, not private IP. When they are in same network, we can use private IP. That also I'm going to show you. Okay. Yeah. Any more doubts from anyone?
Hello, sir.
Yes, please.
Sir, if public IP is regularly changing, then if a person is doing wrong thing, like something stealing money or like that, so how the needful person catch him, or like the IP address will be changed from next time? Okay.
Yeah, I'll tell you. See, first of all, no, that is not how it is. In VPC only, we are going to talk about multiple layers of security. That's not one layer. Multiple layers of security is there. So how we are going to provide that, I can't give in one line because that's a big topics on there. And one more thing I would like to add here. Yes, not for security reasons here. Yes, in some cases where I want static public IP. In some cases where I want fixed IP, but that should not be changed. But that should be of public IP. So there comes AWS, they have given a concept called elastic IP. This also we are going to discuss. Okay, this is only for AWS related part, elastic IP. That also we are going to see. There you will understand. Okay. Any more doubts from anyone? Any doubts?
No, sir.
No doubts?
No.
No, sir.
Okay. Yeah, that's it, guys. Pretty much for today. See you all in Monday's class. Okay, tomorrow Sunday, right? No class. Next class would be on Monday. Okay. Thank you all. See you on Monday, same time. Yeah. Thank you. Have a nice day. Happy weekend.
Yes, sir.
Yeah, based on that, yes, Raju. Based on that, you have to use subnet mask. Can we block only 6 or 11 IP addresses by using subnet mask? No. For blocking purpose, we have no, that is not possible. I want only that IP. This no, you should take in a series, in a range. Okay. Yeah. Thank you. Yes.